Hi everyone. Actually, it's so crazy because I did this lesson once, and then the video, so it was lost among all the videos I did, and then I did it, so I did it again, and then it didn't have any sound, and this is my third time. So I don't know, maybe when the time comes with technology, maybe we are old for that. Or before I used to do a 15 minutes video in Screencast-O-Matic, but right now I am using another software because it lets me to do longer videos. So, and sometimes it goes, it goes crazy and I don't notice. So here, this is my third time to do this video, and it's a very important lesson in derivatives, so I don't mind to do it again. See, here is implicit derivative. Okay, so implicit derivative, that you are just learning. So maybe I can do this, maybe in order you to see it much better. See, before this, you had y equal fx, and you used to have, so you used to say, okay, so y prime is derivative of the other side, so easy. But right now I don't have um, y equal fx. How about if I don't have y equal fx? How about if I just have a relationship between x and y? What should I do? See, I still have x an independent variable. I still have y dependent to x. Y is fx, but I don't know what f is. I don't know what is f. I don't know that. Okay, so I just know a relationship between x and y, which is here. A relationship between x and y. I know x is independent. I know y is dependent to x, but I don't know what is y equal fx. I don't know f. I just know a relationship between x and y. So, for example, 2x plus y squared equal 5, for example. I know a relationship. And I want to find y prime. This is the most, I think this is the most difficult part in derivative for your course. Um, we don't go to too many details for derivative and antiderivative and all of these in this course. So you see a surface of calculus, but still it can be challenging, and this part is a little bit challenging, and I want you to just listen, and hopefully hopefully this time I can finish this video right and you can see it. See, if I have y equal fx, then I have y prime equal f prime x. But right now here I don't have that. Here I have a relationship between x and y. Okay, I have a relationship between x and y. What is my relationship here? 5x minus 2y equals 7. I know here you can solve for y. Yeah, I know you can solve for y, and you can find the answer. So you can say y is y is y is 5x minus 7 divided by 2. So this, right? Am I right? So here, if I take to this to other side, and then this to that side, and yes, I'm right. And then I can say, okay, y prime is 5 over 2. Yes, easy. But how about if I cannot do that? How about if I know x is independent, y is dependent to x, I know a relationship between x and y, which is here, but I don't know how to solve for y. I can't. What should I do? This is the lesson. First of all, you have to make sure that you know you don't start y prime equal. No. So far you did, because so far you had y equal fx, but you don't have that now. You have a relationship. I mention this every time because a student make mistake here. Every time they start from y prime equal, and then they take y prime equal in consideration and in calculation. That's wrong. The first step, you have to do derivative of both sides. Okay, 5x minus 2y equal derivative of that. Okay, derivative of both sides. So what should I do? If I do derivative of both sides, if I multiply both sides, if I divide both sides, so I didn't change my question, okay? So nothing is wrong. So I can do derivative of both sides, okay? Yeah, I can do derivative of both sides. So far, so good. So then all the rules apply. So all the rules stay here. So I have to, for example, derivative of addition, derivative of subtraction, 5 comes out, 2 comes out, all of them, okay? So you do derivative of first minus derivative of second equals 0. So far, so good. So what is derivative of 5x? The same as before, 5. What is derivative of 2y? Okay, here the challenge starts. You have to think it is 2x. What is the derivative? 2. But it's not 2x, it's 2y. It's like u. So you have to find the derivative respect to x in your head, substitute y, and then times with y prime. This is like u prime. Okay? So what is the derivative of 2x? 2. What is the derivative of 2y? 2. But I have to times with y prime because here is u. Y is like u that I did in topic what was the topic? Topic 19. Okay? So it's 2 y prime equals 0. And then solve for y prime. Solve for y prime. Look at the step 3. Okay? So solve for y prime. So y prime is 5 over 2. Look at that. Yes, I know. But I don't want you to go with that method because you have to solve for y. Here you have to solve for y. First of all, maybe you cannot solve for y. And second of all, when you do more work, you make mistake. You make more mistakes. So that's a chance of making more mistakes. Okay? So 2 and 3. Okay? So one more question here. Okay, so how about that? How about this? What is the derivative of y? Again, crazy. Okay, let me see. Okay, my goodness. This was fine so far. I don't know what happened. Okay, something is really happening. Okay, so can I really zoom it? Okay, so what is the derivative of y? Okay, derivative of y. What is the derivative of x? 1. But here is y. So you have to times 1 with y prime. What is the derivative of y squared? 2y, like x squared. It's 2x. But times y prime. What is the derivative of y cubed? How about if it's x cubed? You do 3x squared. Okay, so you do 3y squared y prime. You have to times with y prime, right? So wherever you have y, you have to times it with y prime. Okay, now I continue here. I did this question, done. Okay, so here it says, I just maybe I just can show you this way with this one. So see, it says dy over dx, find dy over dx. I always told you use dy over dx equal y prime, and it's easier for you. But here I can see, I can show you this. Okay, so derivative of that, okay, crazy, I don't know really. So derivative of this one, derivative of this equal derivative of that. Remember, don't start y prime equal. No, 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 no. Here you don't have y equal, so you don't start from y prime equal. Derivative of both sides. Okay? So you do 5, derivative of 5x minus derivative of 2y equals 0. The next step, 5 minus 2 dy over dx, right? So wherever you want to substitute y prime, put dy over dx. If I ask for dy over dx, okay, equals 0, right? Look, derivative of 2y is like derivative of 2x, so it's 2. But I told you, if you have y, you have to times with y prime because it's like u prime, okay? So instead of y prime, I put dy over dx, and then dy over dx is 5 over 2. Done. Okay? So now I can continue here. What is dy over dx? The function is xy equal 5. I know here you can say y is 5 over x. I know, but I don't want that. Okay? Do you start y prime equal? No, 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 no. You do what? First step, derivative of both sides. Okay. xy derivative equal 5 derivative. Now do the derivative. Product rule, quotient rule, derivative rules all apply. Okay, so it is derivative of x times y plus derivative of y times x equals 0. Step by step. What is derivative of x? 1. What is derivative of y? Y prime. Because it's like x, I do 1, then times with y prime. Okay, so y prime equals 0. And then y prime is, xy prime is minus y, and y prime is minus y over x. See, y prime, not like before, y prime is based on x and y. When you have implicit function, when you have x and y in a relationship, y prime, maybe it's based on x, maybe it's based on y, maybe it's based on x and y. It's okay, can be. Okay? So it's minus y over x here. Right? So let me just check my work, otherwise I have to do the video for 4 times. So here is minus y. Yes. Okay, now I do this question. Okay, this question, and then so I cannot zoom, so I write this large. Okay, so okay, I do derivative of both sides. So derivative of, do I start from y prime equal? No, 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 no. I mention this every time. Okay, so derivative of left side equal derivative of right side. When I do to two sides, when I do to both sides, I multiply both sides, I divide both sides. I didn't change my equation. Okay, so derivative of 2x plus derivative of 3y squared equals 0. What is derivative of 2x? 2 plus 6y y prime equals 0. Right? Remember, think it is 6, think it is just what? 3x squared. Okay? Let's say it is 3x squared. And I use the derivative, right? So 3x squared, the derivative is 6x. Okay? But right now I have to substitute y and times with y prime. So 6y y prime. So what is y prime? Now I have to solve for y prime. Y prime is 6y, y prime is minus 2, and y prime is minus 1 over 3y. Right? Done. Okay? So here I have to stop because, yes, I did this. So the first step is, I have to mention, as this lesson is important, first of all, don't start from y prime equal. No, 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 no. If you see a relationship between x and y, if you don't see If you don't see y equal a function, don't do this. Don't start with y prime equal. What do you do? Derivative of both sides. Then all the rules apply for derivative. But when I see y, I have to think it is x, find the derivative, substitute y and times with y prime. And then I have to solve for y prime. So whatever has y prime goes one side, whatever doesn't have the other side. Also, I found I made a mistake. One of the students told me, and I really appreciate here. Okay, in this example. So I'm going to talk about it here. Yes. Look at this. Look at this question. You have x squared y plus xy squared equal 5x. Okay. Do I start y prime equal? No. I do derivative of both sides. Then I do derivative of 1. My goodness. Okay, I think I'm making it so small and it's all of a sudden I lose it. Okay. My goodness. It's really driving me crazy. Okay, so I'm going to finish and start it. Just finish this one and then for that one I do another video. Okay.